I'll try to I'll push the changes from the last stream and I will try to get function calls working. So I'll just say my func like this, right? It prints a, it prints hello, let's say, right? I will just call it, right? So let's see what's broken about it. So yeah, the thing that's not supported is compiling. That's fine. We can compile it. Okay. The groupie DLL is here. What the fuck? So we'll have we so when we have functions, yeah, I guess what this means is that runtime value for function should just be its address, right? So let's see, runtime. So there's runtime type, right? Function. Here this, right? So here I would just say function value, function, right? Struct function value. I'll just say offset for now. We'll also say function literal pointer, maybe. Func. Yeah, that doesn't make any sense. It'll be more like param count, right? Runtime type, result type, and init, I guess. I don't know. This doesn't really make much sense anyways. Let's maybe just return true for function values. Let's see. This can be removed now, right? Hmm. Okay. So now this actually does compile. Okay, that's interesting. Solid function literal. So this is weird because the way I compile it is probably that in declare statement, right? I made functions really complicated on the parser level, so I don't really even know how to make them more sensible. Maybe the way I do this is I have declare function or something. Declare function, right? That would be a new statement type that we output for when that would make a lot of sense. So now here, if value result type equals runtime type function, right? Then we compile a different declare statement, which would be declare function. Say declare function would be expression would be a function literal, right? Fuck. I don't want this. I don't want them to be values. I don't think that scales. Let's just remove that then. Let's just straight up remove that. So this is now variable specific, right? Mm. This does make me feel that we actually want different type scope. Yeah, I'll do that. So we'll reintroduce then. Just say string name. So let's just make functions always be constants. That will make this language way easier to implement, and we also don't need to complicate things. Like, I can also just support like scoped function constants. That's fine. I'm just not gonna support the value that like I will not make functions first class. Basically, is the thing. I don't think that's needed for this language. So here we just say this and this, right? And here this is function type. Yeah, this will actually simplify a lot of things. So when get assign or read so wait, this is in parser, right? Read parser, read assign statement, identifier statement, okay. So now what I think we should do is static statement. Let's try to parse function declaration, right? Parser, like that. And now instead of doing any of the fucking bullshit I did here for ordinary parsing, I'll just say this, right? And for here, trying to parse thing, just say function. Say bool, right? Say if trying to parse parser like this, right? Otherwise, we just say this, right? We'll say statement function declare equals this, right? And now if function declare, we just return the declare, and otherwise we get a value and do that. Okay. Statement bool. Yeah, okay. I still have to convert this. Yeah, will be push statement. We'll no longer have expression function. We'll have statement type be function, declare function like this. Statement. Okay. And now anything that was in a function before. So that's a function literal. And this we can just remove now. And now we'll have declare function where we will have the literal just like that. And function value is something I can just remove, I think. Might need to have an offset here, question mark. No. Runtime type could be a result type. We probably don't need that. We don't need that either. Okay. Just stick with that for now. This is whatever. Function like this now. Function. Player function, literal. Oh. Right, and then we can just say literal runs, right? Or maybe this is function statement and this is just function, right? And now otherwise return 0, right? So this is a return statement, okay. This we can just replace with function, right? And we'll also add arrows. Okay. No longer have this, we'll have it in. We'll have it above, yeah, above declare function, and it's a statement. Actually, one thing that we don't have here is the name. Declare function. Okay. name, right? We'll literally just so here we just say this, right? Instead, here we no longer have to care because functions are no longer a variable type. Here, this thing can just go fuck itself. This thing I'll have to rewrite. Declare function. Okay, well, see about that. So this is statement. Declare function. Literal params. Oh, like this, I guess. Oh no, never mind. It's more like this. Now wait, statement is a pointer, then this is a union, so then this is probably like that. One. Yeah, because literal is also not a pointer anymore. Okay, and this is just gonna be our function. Literal function equals this. Function scope. It's no longer this. Yeah, okay. So that's easy. In parser, we'll say the same things where we'll do function. Literal function equals. This is statement. Declare function. Literal. Address of right function params and function scope. Okay. Okay. It's easy and we no longer have to have that. Good. Good, good. Yeah, I'll have to fix that. Yeah, functionally there is something I'll fix in a sec. First, let's fix the parser. This is function name. Just print. Just print it. Print f function name. I think it's like this, right? String format, and we'll pass it here. Yeah, so now read call expression. That really no longer has to be this like thing. All this has to now do instead. So this would read primary instead. And what we need to do is an identifier. Once we no longer have anything, we'll have it here, right? So now if we accept an open parent, we would just say this and we'd return the function call, right? This is the statement, no. That is interesting, okay. So it's not here actually, it's somewhere else. It's in here. So now else if, yeah, okay. So this is now correct. And now the function name is the identifier. So we push string parser data arena, and oh, actually, this can be AST arena. Right. And it would just be it would just be the token, right? And this is just the token. Okay. So now parser is done, and now that means we can adapt function call to be correct. Function name. This we don't care about. And what we need here is function type. Func type equals get function type resolver type scope token, which is expression token, right? This has to be a string name, right? I suppose I can just straight up pass here and then check parent scopes. We would say yes. And function type, we would just say function. Function is the func type. The function, right? So we can just say this instead. And I guess let's grab that error that we had there. So here we would just say, oh yeah, I don't have to pre-resolve anything here. And the function is just this, right? But we would say if the func type function is this, is function call on invalid function. And now this needs a token, right? Expression token. One will have statement token. This one will have statement token. Expression token. Yeah, so here we need just string name equals expression, or rather, yeah, express. Fuck me, honestly. String name. Function call name. Oh my god, why did I name it function name? Okay, don't have to resolve an expression. Just say if now function call. Oh yeah, what I need is like a function type. Func type equals get function type. Scope. Expression token name true. So now if func type function, right, if there's function call on invalid function, just say that, and then function just func type function. So all this, I guess I can do this instead. Okay. Yeah, so now this is simpler because all we do is we say declare function, right? And the statement is declare function name equals main, right? And then anytime something is an undeclared, and then anytime something is an undeclared function,
or it is the main function, right? Because at this state we can just say if something. I don't know. Actually, that doesn't make sense because this is called in two places, so it's not worth it for me to duplicate the code. And now function, literal function. This is not a declare. This is a declare function. It has the literal, and now this is one declare value val. This would be the scope, right? Okay. Function, yeah, this is no longer a thing. Okay. So do we still work? We don't seem to work. Oh yeah, the reason we don't work is because we need a name, I think. Although that's probably not enough, actually. Wait, one. We just need identifier odds, right? And now what we do is if we had this statement parsed correctly, we'll say declare function name equals push string. We'll say what parser. Say AST arena, and we'll say we'll just use one. What do we use here? We use the name, right? It should be in. Okay. What do we get now? Hmm. Wait. Try to parse statement, right? Parse restore state, accept non-reserved. I think I'm missing a thing here, right? It's like if accept so wait, this is here, right? This is like lecture accept token, right? Parser lecture token type. This is like open parent, right? Okay, and if we accept it, this is where we say all this stuff, right? And otherwise return 0. Hey, Miriam. Maybe the way to do this correctly is like. So why would we even like bother with a statement if we haven't parsed something? And what I would say is this function, right? And we would just keep it on stock. I mean, we push stuff here anyways. So maybe what I do here. Oh, it also rewinds the arena for me, so I don't even have to worry. I made this very well. Okay. So I can't even do it here, although it's kind of wasted word. It doesn't matter though. Okay. So now I think it should work. Oh. That's funny. Right. So I have to now do bool don't check force, right? And now would be false, set the false, right? And now if no, don't check force, then do this. This is double negation, so it's kind of stupid. I'll say true by default. Check force, and now if don't check force, and here we would just always say false. Because another thing we could do is parse this here, right? And then always, and then in recursion we would always say false here, right? Check parse is the name now. So now if we check parse, check funcs, I'll say we don't check funcs, but we do just check it, whatever, and then you also don't check parse when we recurse. So we just do it once. I think that does it. So weird. Okay, there are two calls to this. Good. Okay, and now it doesn't seem like our try parse thing works. Try parse. Try to parse function declaration, right? Oh. Parser, lexer, current. So let me actually see if I even accept an open parent here, right? I do, okay. so this is all awesome. I don't know why I don't. I think compiler is where I print them. It's probably not where I should print them. So let's see what I have here. My global function, declare function, parameters, none. Okay, so in declare function, when I print it, so print statement, right, should say, I don't know why I don't start the name in the literal. It doesn't really make that much sense. It's like the only place I do this anyways. So let's just do function literal. Let's just do that instead, and let's have declare function as a function literal. It's kind of stupid, and obviously I need the string format. So yeah, declare function, parameters go. So that's all good. Oh, I see. So my problem is actually, I mean, I basically don't have a problem is the thing. Don't think there's anything to resolve here, honestly. On the pre-resolution stage. All I need to do is like declare type. Yeah, okay. So all I do is name and then, oh, look at it. It's so complete now. Don't even have to do that. Function name. What I need to pass is this. Now result type. This is something I don't need to pass. XD. This is also just function. It wasn't even used here. Elmo. Don't even need to do that. So do we get now? Can't declare the same variable twice. That's stupid. Also kind of stupid, but say don't, and that should do it. Unsupported expression type in the compiler. Okay, so it doesn't support function calls, right? I think it already supports functions to some extent, so that's really good. Okay. No, we don't support functions yet, but we support scopes. And that's really all we need for functions. So what I would do here is I would say statement, function, say scope. That's what we have. And if it doesn't have a scope, that's a bigger problem. I would just say compiler error. Compiler statement token. Function has no scope. Okay. Here I also say that if we assume that this sets the error button. I guess I can say had errors true. Anyways, to be sure. So the expression as if type function call. Do. It's funny because that means we don't technically support. I mean, we should just do that, honestly. So if we compile, let's queue the function. It's done, right? And now what it'll do is it'll add statement type, declare function, right? Say this, and we'll say compile expression. Further compile statement, compiler, compile. So this is the declare function, and it will be the scope, right? We'll break here. Function has no scope. Move it above declare function. Okay. So this should technically just allow me to make this function the thing. Statement, right? Turn up code is something I can finally remove. Because what we'll do instead is we'll have a return statement inside of declare function compilation like this. I'll say just code, bytecode return. Okay. Okay. I'll be in 1 sec. Okay. So now what I'm thinking is that I will probably temporarily store a function offsets as a table. I get dumb, but whatever. And now basically anytime we compile a function, we would say. So first let's make this function literal also have like a function pointer, function or slot maybe. And now anytime that would actually be in resolver. Resolver would just have like a function slot or something. Yeah, fine. I'm sure function slot can be. And now anytime we declare a function type, what we do is we bump it. So we say function dot slot. So we'll just say function slot equals resolver function slot plus plus. So it just means let's grab yet another slot. Should probably add limit checks at some point, but whatever. And now what we should also do is in function calls, should say function call. Since we get the function type, we will say function slot equals find type slot. Okay. Oh. Oh. That's actually don't have to do any wiring because we already have store a pointer to the function. Right? Function call. Oh no, never mind, I do have to. Okay. I'll just say. So this can be in mind. And then slot equals function slot. Like this. Okay. So now what I can do in the compiler, I would just add a new opcode called call. It's like whatever. like generic or whatever. Call. And now when we have expression. Actually, this whole resolution thing is wrong. Shouldn't even be in the resolver. So let's undo what I just did, and we'll do it in Q instead. Or can we though? Can we though? That doesn't even matter though. Like, I can probably use it. Because I don't have to... Main doesn't have to be function 0. I don't really care about that. So let's actually undo the... Undo the undos, basically. Okay. Yeah, that's fine. That's still fine. So what I would say is once we say compile it, right? Once we compile it, we would say so this is like the code segment we want to store code arena pause, right? So this would be pause. Or rather we would just say program compiler program. We'll just say this, and here we'll just say declare function. Stop like that. Okay. And now for function call, actually, it should be really fucking simple because all I need to do is segment push u8 opcode call, right? And then the next thing is just expression function call slot. Okay. And that's it for the compiler. And now for the runtime, we will say we'll just say what do we do? We have to support the call. Now what we need is call frame. This is basically the state of PP of the IP and of the SP. So this is all this, right? Right. Think so. Right. So we'll say all frames 64. We'll have to add more error checking. Let me note this into the say see here on error checking for frame for call frames error checking for call frame. There was something else I also did. Maybe compiler is like I had some 256 array that I hard coded somewhere. I swear I had a 256 array. I declared like this. Whatever. So what call should do is runtime let's say u32 call frame count, right? Like call frame count plus plus. Say run time. We'll just make it equals call frame. We do add error checking. And other array, other limited arrays. Forgot. Say maybe variable related. Oh, I guess, and function slots, function slot. So that's actually, that should be in the runtime, right? No. Yeah, that's in program. And program is in the compiler. Yeah, here. Function slots and globals also think of some way of reducing, of loosening the limits. Okay, that's fine. Eventually, functions offset would probably not be a thing that's made on frame. Yeah, that would be on runtime. We would just actually output the address of the function into the thing. So okay, opcode call frame. Let's say bp equals program. Oh, that's wrong. Wait, this is the runtime? Yeah. Okay. Never mind. Could confuse. So we say bp ep sp. bp ep. So you basically like store the. You kind of store the CPU state, we could say, the registers. And now just move it. And we also say runtime ep to runtime program function offsets, and the offset would be the slot, right? The bp we would say to sp. Done. Okay. Okay. So we don't have parameter support yet, but that should be something we can just add in the compiler pretty easily. Yeah, I think that should be fine. Do we actually... Does this actually work? It does say hello. But now the problem is we don't actually return. So if I would say here, I would say hello to. This is like a go-to, right? It doesn't return, doesn't do hello to. And the reason is because we have to pop the call frame when we return. So let's move return to be here because they're closely related. And we'll just say if the call frame is a thing, then we'll just say call frame, right, equals this, right? But we instead of post incrementing, we'll pre-decrement like this. And now we just say runtime. We invert this basically. We restore it. We'll do it like this. Okay. So now we should see hello too. great. We have function calls. Now, one other thing is doing. We also have a limit of 256 globals and 256 functions, which is stupid as fuck. Where I shouldn't have any limit for either. Maybe the U32 limit, because like we use the dynamic arenas to allocate stuff, so we shouldn't need to even store the arrays. We currently do because it's just easier, but whatever. We'll now want to pass it a value like this. And to do that, in the compiler, we'll have to say, specifically for function calls, we need to say for expression function call args, right? There's, we'll say argument arg equals this. We'll say arg equals arg link next. I guess all we need to do is just compile expression and then arg, right? Arg expression, that's all we do, right? And now for each argument, we should also count how many pop ends we need to do. We'll say pop n was equals 1. And now we would say segment push. I guess depending if pop n is here. I should really do something smart here because this is useful. So we'll say segment push pop n, right? And we'll say pop n, right? And now, if no pop n, then we don't do anything. If pop n equals 1, we'll say we'll do segment push u8 upcode pop, right? Segment pop, right? Okay. And otherwise, we'll say segment. Say upcode pop n. And we'll say the pop n like this. And I guess right now, if pop n is more than this, we'll say compiler. Yeah, let's not do that. Let's for now make this a u8, right? Pop n, right? So this would be pop n without this, and we'll say segment push pop n code pop n, right? We're popping the Necron. Okay. So let's see where we also do popping. We do it here, and here I would just say segment push pop n. Say this. Yeah, okay. Okay, so that should be the only other dynamic pop n. Okay, so now should be able to see hello 10. And then we should be able to see hello 2. But it says hello, hello. So we have something wrong. Yeah, so I think the reason is because BP we should save before pushing those additional expressions. So I think all that needs to have is BP minus the runtime. should how do I do this? Because I can either could also say function. Let's just say for now extract function, right? And this is the offset, u32 offset, and also we would have the arc count. Say functions, function array. Okay. We'll say other checking for functions. Functions like this. Okay. So now this is just a functions. This offset, right? So let's grab this like this. Function equals this. Function offset. Function arc count. I'll just say 0 and we'll say for you for this, right? So parameter equals this, param equals param. Like next, right? See first, right? And now I will say count equals 0, count plus equals 1, count is here now. Okay, function offsets. We'll just say functions. Function equals this, right? Function offset, and we'll say minus function arc count, right? Yeah, okay, because params are actually the first thing is resolved, I think. So that should do it. Question mark. And also I think what I can do is use address of here because that's probably faster. Not have to copy it. It still says hello, hello. Let's see. Yeah, let's see. It says arc count. Oh, I see. Oh yeah, because this is what we would come back to. And I think what we just need is this. And we don't even need that. Do we need that? No, we don't. Okay. Yeah, it works. Okay, let's try something more complicated. Let's also use my global. Let's also say like yard equals if you're free, and we'll say yard here. Okay. We'll also say like z equals 69, and we'll say y equals 420. Okay. Yeah, all seems to work. Let's have Oh yeah, one thing we don't support yet is return value. So if we say int, so let's say we have a function that doubles an integer, right? And it returns an integer, and it should just return I times 2, right? This doesn't work. And I would want it to work. So this should be just double. Yeah, it's unsupported for the compiler. Yeah, I think that's not that hard. So let's try making it work. What I need to do here is um hmm, okay. So what I need here is for statement. So statement time. We have a statement time. Oh, actually, I have no idea how to do continue and break yet. That's interesting. I mean, those are probably just jumps to something. Return signal. Okay, so now if we have a value, we compile it. And once we say, return, I think I'll also have return value, right? Like this. We'll make them like this, okay. Turn signal, right, okay. So that should do it. And now what return value should do. So what we do is AI runtime. We'll say return, right? And now return value is the same kind of thing. It's just it also pops a runtime value equals runtime pop value, right? Runtime. And then it pushes it after we unwind the call frame. This push value runtime value. I think that's what it is. We get 10 though. Let's see what we get here in return value. It is 20. Okay. And actually, this should like push an empty value, I think. Because the function call is an expression. Statement, right? So it should technically always push a value. Do we work now? We don't. Oh, because yeah, we actually don't want to go back to that state. So I think what I will do is I will set up the stack to be smaller than the arc count. And then we'll just maybe like this. Oh no, no, I'm wrong. Wait, am I wrong? Oh, because we don't actually want to change the stack pointer for when we are actually in the function. So we just want this. We don't want to actually write to it, right? Makes sense. And now we have something wrong still. That's interesting. I wasn't wrong in a moment ago. So what do we break? Yeah, this is here. The base pointer. Wait, was it correct? No. Yeah, this one shouldn't be changed, I don't think. Yeah, the base pointer should be where it was, and the stack pointer should be without the RX. But now, in the function, it seems like we are completely busted. I don't really know why. Is it because of the double? Yeah, it is. Hmm. It's very interesting. What if I at least do like... I see, it actually did return it correctly here. So does that mean we're off by 1 or something? Do I have the +1 here? Oh, I do! Right. Or do I? No, because I push value later, so no, that doesn't make any sense. So when I actually am here, right, I'm back to the call stack. What do I see? I'm 4. And then it's 5, right? So let's see the stack from call and stack from this. So I think I skip one call and now I see the other one. So SP is 5 at this moment. We have our param here, right? Yeah, okay, so now we're back at 5. Fifth element is 20. Okay. Okay, well, I don't have time to debug this. This is... We almost have calls, so let's just, I'd say, so here we'll say, add support for functions, we'll just say fix stack issues for function calls with return values. I'll say question mark. With question return values like this, I guess. So yeah, I will see you guys later.